Okay, that's good. So, uh, it seems like you've guessed the point. You should like prove it. Yeah. Well, try to like find some like harmonics and stuff in this. It shouldn't be that bad. Wait, like, do you guys all get like, does the question make sense to all of you? Mm. Okay, yeah. So, do you guys have any ideas? Siva, and like, do what? What do you get with that? Okay, if you want a hint, I think this guy might be useful. If you draw on this line, like, let this point be like, I don't know, let's call it like M. What's M? Oh, it's Tarun, my goat. Yeah, try to identify M in this picture. Yeah, it is. That's good. Yeah, it is. Good. That's a pretty good guess. So you get that it's the harmonic conjugate of B. So this is the median. So then let this point be K. Now prove that hmm, wait, actually, you have to prove this might it does lie in QAPT actually, but you have to prove that. I think it should, yeah. And proving that should solve the problem. Yeah, basically. Yeah, you just chase harmonics and then you can just use like Pascal and then you get that these are collinear and then that's basically it. It's kind of mid. But this is gonna be useful. Yeah, you do this. And then you use Pascal on I think this guy, this uh and I think It's definitely this, and oh that, yeah. So by Pascal on this, you should get that AVPN. So you get that, yeah, you get that QC, symmedian point, QA. You get that these are collinear, and that's it basically. Yeah, it's kind of cool. Okay, now let's start to get to the actual X points. So I think you guys should all know that. Oh shit, what the hell is going on in the chat? What the hell? Yeah, I think you guys should all know that like AD, PE, CF concur at one point. We call this point Gergonne point, like this. And do you guys know how to prove this without like Siva? It's like pretty easy. You just take like homography, yeah. Or Korea. I mean, Siva's bad, so like, yeah. Yeah, pretty easy. Hom yeah, degenerate branching that also solves it. It's really easy. Okay, so prove that uh oh, I haven't drawn this. Crap. This is just IBIC, and let's just call CV nest. I'm stupid. This is like pretty easy. It shouldn't be that bad. So here's a hint. Guess this point in relation to these. Like, guess what this is given XM. Yeah, it is. Actually, since you guessed that, I'm just gonna move to this slide. So now I have a diagram on it. Oh wait, that's a big spoiler. Actually, I see MC, symmedian, and that. Yeah, you just take the main guess you have to make is that this guy is equal to the um like homosity of this guy from G by -1/2. So like, oh what the hell? Who's drawing on this? We call this like anti-complement, by the way. And the reason for this is pretty easy. It's because you have that AG, this line, prove that this line is actually parallel to uh this line, like IAMA. So on like this diagram, it would be, for example, and I is gonna be like that way, right? Like IA. So just prove that these are parallel, and then you're done. Yeah, it's what the hell? Okay, yeah, it's pretty easy. You just take like some homosity, I think. I think it's from like, yeah, it's trivial. You note that this point by homosity at A, this is like the top point of DF. This is like D, I'll call it D prime. So then just take, oh wait, no it isn't. I'm dumb. Sorry. You should get that. You take homosity at this point. Like this is gonna be X touch, right? So let's call it D prime. And it's well known that uh yeah. And then homosity from this, it will send D to MA, and it will send uh it will send the bottom point of the X circle. So let it be like D prime antipode. It'll send this to IA. Like basically, does this make sense? You just take a 1/2 homosity at D and you get that these two are parallel. And then just do the same thing on all three sides. So yeah. Does this kind of make sense? Like if you guys don't know what this point is, it's just like this. Like X circle. It's like no, it's the antipode of the X tucked point, yeah. Okay. So as Tarun said, since IAMA, that's a midline of BC, and you have that this is cyclic, right? Because, 90 degrees and stuff. So since these are antiparallel, so the median of this is just the median of IC, IA, IB. That should be pretty easy, right? Okay. So yeah. So you get this. And also by like harmonics, you get that this, 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 this is harmonic, right? Oh, this is a typo. This should say homothetic. Yeah, and you also get it from this exact diagram. You also get x25 by doing homosity at this, this, and this. I mean, sorry, it should be at lithic. Yeah. And now let's get to the actual interesting part of this lesson. Here's the Fermat and isodynamic points. You guys have probably heard of these before, but plane geometry. It's the one in my bio. It's the book. Yeah. So, um, this is just the definition, and isodynamic points is just isogonal conjugate of this and this. So hopefully this makes sense. Okay, and now let's prove something about isodynamic points. Let's prove. Do you guys all know what Apollonian circles are? It's like if you have B, C, then like constant ratio of points, like constant ratio of distances with like respect. Yeah, yeah. So prove that these will meet in two common points. And I think this is really cool, like the proof of this. Use trilinear. How? Wait, like coordinates? Uh, yeah, that's true because it's harmonic and stuff. So yeah, so that's a good observation. So you get that, yeah, this. So okay, um, do you guys have any ideas? It's really nice. Uh, there's three. It's like B, C, and A, and then like A, C, and like A, C that goes to B, like yeah, and then like A, C, A, B that goes to C. Okay, then they're not coaxial. Wait, yeah, they are coaxial. Sorry. Yeah, show the coaxial. Good job. At what and how? Okay, cyclical inversion. So you want to draw an ABC? I think he's cooking. And midpoint at BC, that wouldn't do anything. Yeah, because you don't know what D goes to after that, I think. Yeah. Wait. Oh, like, yeah. Yeah, because okay. But then you can't deal with A then, right? A is gonna go to like, yeah, something bad. Okay, here's the thing. You want to do a root BC. What would a root BC do to this? Wait, what? Did I get kicked? Uh, oh, that's bad. Okay. Anyways, the proof is root BC at A. So, this will the main like observation is that prove that these are 90 degrees. Prove that like orthogonal, basically. And then it should be trivial. Okay, so do you guys see why these are orthogonal? I mean, it's pretty easy. Anyways, so just take the inversion and you get that ABC, this is gonna go like ABC, that's gonna go to what? It's gonna go to BC, right? So it's gonna go to this. So what's this gonna go to? Yeah, D is fixed. It's like the one that passes through A. Oh, no, it's not. I do root BC, it's okay. So it's still gonna be 90 degrees to ABC, right? Because like inversion. So that means it's actually gonna go to the perpendicular bisector of BC. Similarly, like, does this make sense? Okay, so similarly, by inversion at like of the AB uploading circle that goes to C, it's gonna look like this basically, like this circle. Inversion of this, that's gonna send it to a circle centered at B that's orthogonal to ABC, right? So it's gonna go to like I'll just I'll just it's gonna go to like this a circle centered at B that goes to C. So your final diagram is gonna look like this. Does this make sense? Like the image of like this uploading circle is gonna be this guy. It's gonna be like this guy. And the image of like uh this uploading circle with foci AB is gonna be this guy. Yeah, good job. Wait, what? No, it's a median point? It should be from on point, no? Oh, line connecting isodynamic points. I'm illiterate. Yeah, that's probably true. So, and now, so 2 points is just going to be the root BC images of this and this. Does this make sense? Like, do you guys all get this? Okay. So that means that these points, let's prove that these points are actually isodynamic points. Well, you have that, since we did a root BC, we know that, like, this is line through Fermat point, right? But it's also the isogonal conjugate of the line through the opposite circle thing. Because if we did a BC, that's like reflection, right? So that means that these two are also conjugates of isodynamic. I mean, sorry, conjugates of Fermat point, and we're done. It's a pretty fun problem. Okay, here's this is a cook. Take that to interpret what you mean. So let take A B. I picked the exact X end in this lesson to be all doable without any batching of any sort. Like you don't need any like lines tracing, you don't need any complex, any berry, you don't need any of that. So like don't do that. And this will lead to a very funny proof. I mean, it probably is. And no, it doesn't, I think. Does it really? Does com can I like move? Oh, what? Uh, how do I? Okay. You know what? I'm gonna eyeball it. Good enough. I don't care. It's like a 9 point circle. So like obviously by symmetry, you can just prove that like the Euler lines of ABC and BIC concur, right? And like some symmetric point. So like do that. Thanks for the in circle. So do you guys have any ideas that are not complex? Um, I will not elaborate on this, but like X21 is Schliffler point. No, okay, right now we want to prove that like the Euler lines of ABC and BIC concur at some like symmetric point, and then we just win by symmetry right now. Yeah. Don't draw that in yet. Okay, so circumstantial, what is that? It's just gonna be by like chicken foot lemma or something. It's gonna be like, it's gonna be this point, like midpoint by chicken foot lemma. Hyperbola. Y- Uh, yeah, that is what you do. Good job. He guessed it. So after you draw in the hyperbola through A, B, C, H. Wait, do you guys know like hyperbola theory at all? Yeah. So the only amount of theory you need is that if you have a hyperbola with asymptotes at 90 degrees, then this is the only theory you need. You don't need anything more. Then a triangle inscribed in this, the orthocenter of this triangle, it's gonna lie in hyperbola 2. Triggerful lemma, it's a dumb name I have for incenter extender lemma. Because it looks like a chicken foot. Yeah, it's yeah, they are. So, and the way to prove this is you isogonally conjugate it. By like, if you guys know like moving points, by like Zach's lemma, the isogonal conjugate of any circumconic is gonna be a line. This is because by Barry you get that it's gonna be degree 4, but by moving points it's gonna by Zach's lemma, since it goes through A, B, and C, you get a -3, so then it's just 1. So that's a line. It's pretty funny. Okay, so we get that. Well, we know the isogonal conjugate of this. It's gonna be a since if you want to prove it goes to H, right? So it's just gonna be a line through O because O is the isogonal conjugate of H, right? So here's O, and this line through O. And now, how do we prove that these asymptotes are 90 degrees? Well, intersect it with the line in infinity. What's the isogonal conjugate of line infinity? Well, it's gonna be ABC, right? You guys should know that. Yeah, and then you just win by like Thales theorem, because like these points in infinity, they're just like, yeah, Thales theorem. It's pretty easy. So that's pretty funny. So now that you take that hyperbola, it's gonna take the hyperbola through A, B, C, H, and I. We call this hyperbola the yeah, H. Oh, you fuck. Yeah, you said so many times it's like in my brain now. So, this shouldn't be a K. So what is the isogonal conjugate of this hyperbola? Yeah, it's that. It's the isogonal conjugate of line OI because it goes to I is its own isogonal conjugate, right? Well, okay, step one is prove that II is tangent to hyperbola. Like prove that no, sorry, prove that IO is tangent to Feuerbach. Well, what the heck? This should be easy. Well, is this obvious? So do you see the proof? Yeah, because okay, by like Bezout's theorem, you know that a conic and a line can only have two intersections at most, and these are already just I and I, since I is its own isogonal conjugate, so it's trivial. So now you win by Pascal. I claim so. If you redefine Shiflet point as HO cap Feuerbach like this is symmetric, right? So this is basically what we want. So now we want to prove that um the orthoside of BIC, no wait, the circumside of BIC and the orthoside of BIC HA. We want to prove that HA um HO cap Feuerbach and OA they lie in one line. And this is clear as Pascal, right? HA Schiffler HA, right? So by Pascal, you have that since AH, HA, and OA, these are all 90 degrees with BC. So these concur at the point of infinity perpendicular to BC. So then you just win by Pascal. Does it make sense? Like somewhat. I'm sorry you lost like half of you, but like this is just such a cool proof and I really like it, so I had to show it. Um, do you guys want like more clarification and stuff? Like, do you guys all get this, or should I explain some more? Please speak up. Like, I know there are people who don't get this. Okay, it's your loss. Okay. Time for X40. X40 is, oh, you just joined. We just cooked something with hyperbolas, so you missed out, I guess. Rip. So let even point be a reflection of I over O. Oh, crap. Uh, yeah. Yeah, prove this. Complex. How do you even do like X and wait, that is not like I. You know what? I'm gonna How do you even do complex on this? I'm gonna pull out GeoGebra. How would you even do Barry? It's like close. Wait, actually, it's very easy. I don't know how do you do reflections in Barry? Yeah, prove that. It's a lot easier than you think, I think. I think I put, wait, did I forget the proof? I think I might have, but I remember it's really easy. Oh yeah, it is. Because you just have that, oh yeah, I see. You have that, yeah. It's because orthology at this. Y- yeah, you have that, the penal triangle of I in DEF, that's gonna be ABC. So we know that I is gonna be the orthocenter of DEF, right? This is a small lemma that you should probably know. Do you guys know what orthologic triangles are? So for a point P, let PA, PB, PC, let these be its penal triangle, then I claim that these perpendiculars to this, like this, these will concur in the isogonal conjugate of P. And the proof of this is just like trivial angle tracing because you just have like it's like this equals this because like stuff. I think you draw like this cyclic, and then like this guy equals this guy equals this guy. It's like easy. Yeah. So that's the main lemma you just use. And since this guy is perpendicular to AB by homosity at I, then it's homosity of like this. Yeah. I- Uh, yeah, it is. But also like logic triangles are pretty useful. You should probably like know about them. How do I? This is not the main lemma we will use. It's just that it's gonna be useful. Okay, and now we're back to cooking. So let's do cosine of point. We define it as the isogonal conjugate of the 9-point center. Prove this. It's gonna be like what? It's gonna be like that. Yeah, that's true. Wait, what? A and 9 and A center? Oh, as in OA. I think he means OA. Actually, it's probably easier than that. Like, it's because yeah, that I think that yeah, that's a easy proof because you have that. Like, let this be AN. A, like n is 9 plus header. then we have that by like similar triangles, you should get that this is equal to AB and the orthocenter of BOC. I mean, no, sorry. Wait, how do you? Oh, I think I remember. You draw in this. Like, draw in the orthotic triangle of ABC. Let this be HA and I mean HP and HC. I need to omit this guy. And then you have that this. You just have that it's ortho it's yeah, A and 9's what? It's not. Yeah, there's no way it is. Okay, then you have the circumcenter of ABC. What's that gonna be? So you have circumcenter of I'm sorry, of AHBHC. So of A HP. You have that this is just gonna be equal to the midpoint of AHA, right? By like homosity. And then you have like yeah, and then just take the similarity that sends ABCOA, like that quadrilateral, to AHBHC and like this midpoint. Does that kind of make sense? Yeah, because you have that these are similar since it's both like a AHBHC and ABC is similar and circumstances, right? So, and then by that, you just get that these are like backwards similar, right? It's like oppositely oriented since these. So then you just have the AHA and uh yeah, you have that these are orthogonal. Wait, no, you should have that this like sorry. You should have that this and yeah, force overlay proves that. Oh, just a force overlay? Wait, how? How's the force overlay? Wait. Okay, whatever. If you just proceed with the angle chase, you can just yeah, you can just get that uh that these are orthogonal because yeah, because you just get some angles equal to this, I think. Yeah. It's not that bad. Because by the similarity you get that like this and that, they're like negatively oriented, basically. Yeah. But that's like not very insightful. This is the fun one that I wanted to get to. So like yeah. So if you don't remember Shifter point, it's just the Euler line of A, B, C, I concurrence point. So let's prove this. So let's first redefine some stuff. Like instead of arc midpoint, what do you mean? Oh, like BIC? I don't know. Something bad. Wait, what do you mean by instead of arc midpoint? Well, okay, anyways. So this is equivalent to this since we did like this is all defined symmetrically basically. Like just do like this, and this. So then just take a homosity I. Wait, did I define G prime A? Okay, yeah. So let GA let GA be the centroid of A of IBC, and let this be a reflection of I across GA. And let this be the arc midpoint, and let this be x-centered. And then this is clearly just the Euler line of IBC since centroid and circumcenter, right? So now just prove that since the velocity of NA and B and C at I is going to be IB, IC, right? So then just prove this. And this like looks a lot less intimidating, I guess, right? Uh, do you guys have any ideas for this? Actually, I should probably. Do we have time? Oh, you're back. Okay, midpoint consider. So like consider point of NA and B and C. Yeah. And then we took velocity at I that sends NA to IA and B to yeah. This is centroid of IBC. Okay, let's move on. So now if we like by like if you draw this parallelogram like the one in like isogonality lemma, you should get that J let this be reflection of I across MA. It's not isogonality lemma. It's just because it looks like it. So what do you have is harmonic in this. I mean, that makes sense. The whole lecture, I'll probably go until like 8:30 because I have stuff to do at 8:30 also. So there's still like 45 minutes or so left. Okay, so what's the harmonic in this? You should be able to see this pretty fast. Just take a guess. Bro, it's not that deep. Okay, it's just this. Why is this true? Oh, like length ratios, right? Because this is 2 to 1 and that's like, yeah. Oh, J is parallelogram point of BIC, like reflection of I over MA. So it's like 2, 1, and that's 3. So like, I mean like 6. So like, yeah, it's trivial. It's the same as like the I, it's the same as HG and 9 1. Wait, what? Yeah, it does, but I don't think it's useful in this. Like, you just have the I and J orthogonal. I mean, isogonal, right? So then, since what you have is harmonic in this, you have that I G prime A, I mean sub A. You don't use it just yet. You will use DDIT soon. Don't worry if you want to use DDIT. Oh, you lied. So you have that this is harmonic. Well, what else is harmonic in this? Well, we also know that with complete no motivation, let's guess that, well, we know that O and GH is harmonic, right? So, and here's the part that it has completely no motivation at all. I don't know how they came up with this. So, if you do this on like, if you do this on the X central triangle, what the hell is going on? Okay, so do this on IAIB. I see. Then what do you get? You get Bevan, like let's call it, and then just I. Well, this is also harmonic, right? So let's just draw that in. And somehow this immediately kills it. I'm serious. Do you guys see how this finishes? Yeah, the finish from here is like easy. This is just like a completely insane step of reasoning that I don't know how they came up with. Well, why is IAJOI calling you? Yeah, that's my reaction as well. Well, IAJOI calling you, it's because DDIT at BCJHI, right? So yeah, it's by DDIT. Or like isogonality lemma, same thing. Because you see it, right? It's just DDIT at this, and then the parallels to these, which are isogonal. So that gets us that HINAIA collinear and this collinear. Oh, on it's the goat. It's the goat Math Louise. You do on this quadrilateral, and then you do DIT on that. So that gets you that IAJOI collinear. That's step one. Then then how do you so I claim that since you have like 2 points of the harmonic models, like projective, like a projective map setting HI to HI, setting J to OI, then there is some like nice thing setting MA to GI also and G prime A to NI. And this is just by like DIT like assistance theorem. And do you guys see what this involution is? The DIT is simple. It's just on BHICJ. Like, make it in red. You do it on this. So what is the since HI, NI, GI, OI of X central triangle, since this is equal to HI, MA, G prime A, and J, since you have these equal, there's some involution swapping this guy, this guy, this guy, this guy, this guy, this guy, and this guy at IA, right? So I asked you what is this involution? Well, we already have the OI and J swap. I'm sorry, that OI and HI swap, and that like J also comes with it. So we just need to find one more pair of points, and then we get this involution. So what's the easy pair to do? This is like trivial. Okay, so just find two like points in this like corresponding set that have a nice like involution at IA. Wait, do you guys get what I mean? Wait, do you guys like get what's going on right now? Like, is there has to be someone lost right now, right? Explain again. Which part should I explain? Oh, that's just the cosine point problem that I showed from before. Oh wait. Oh, sorry. Wrong message. Okay. I can tell you guys I lost because there's no messages in chat. Um, do you guys like see anything that you can do? Yeah. How and why? Who is the Korean guy? Yeah, MA and so yeah, that's correct. So you since so by we have that OI and HI swap obviously under isogonal conjugation at IA, and you also have that I claim that IA-MA is a symmedian of IE-IB-IC because BC and IB-IC are anti-parallel since this is cyclic. So then you also have the other involution. There's some involution swapping MA and what's it called? And G of I also, right? And the unique involution that swaps this and this is just reflection across the bisector of BIAIC, right? Since these are isogonal conjugates. So that means that since these have the same cross ratio, you get that this involution also swaps G prime A and Ni, right? Which are just these. So, and so we already proved that this, that, oh wait, these are mixed up. This should be like this. Sorry. Yeah, we already proved that IACA, this already goes to the point. So then we just have that IANA and IACA, C prime A are isogonal conjugates. So then we win because we proved that this goes to like N. Yeah. Did does this kind of make sense? So you just have that as a summary. You just have that this and this and and this. They are all isogonal in AIAOI. I'm sorry, IBIAIC. Yeah, this is really cool. Yeah, that's what I said. So here's something useful that will be used like twice. Also transversal. Yeah, DDIT. Uh, yeah. So prove that if you like, so a point P, prove that if you draw AB, BP, and CP, then take like 90 degrees, add this guy, like such that like this is 90 degrees, and then like this is 90 degrees, and then you intersect these with AB, BC, and AC. Prove that these line one line. So explain the DDIT. That is correct. Yeah. Bro, I don't know. Like, can you guys like talk in chat? I don't know how lost you guys are. Like, I can explain things if you want. Like, you guys are just like not talking. Okay, if you don't know what you can no, use the chat. Like, there's a chat. Okay, he's doing MMP. Someone's doing MMP. Okay, so did I ex do you guys all know DDIT actually? You guys probably don't. If I explain DDIT really quick. DDIT, yeah. Okay. I apologize. We use DIT like a lot, like before. DIT is like this. If you draw like this line, like for a point P, then if you draw like this line, and this line, DIT the DIT is one line, and like this line, then I claim that there is some like projective involution that swaps this guy, this guy, this guy. If you don't know what projective involution is, it's like if you project this onto like a fixed line, then this will like inversion across some circle that sends this to this, this to this, this to this. That's DIT. And the form of DIT we used previously, that was called like the isogonality lemma. And that one is basically like if you have like a triangle ABC and you have like a parallelogram in it, like this, then by using DDIT on this this quadrilateral, you should get that this some evolution swapping this, and this. And in this case, since the evolution swapping AB and AC is and these points at infinity is just isogonal conjugation, you get that these are also isogonal conjugates. That's like the quick explanation of DDIT I have. So here I use DIT in a very funny way. Note that rotating a line by 90 degrees is an involution. Like if you do it twice, it goes to itself, right? So in this case, note that there's an involution swapping AP dP by rotation at 90 degrees, then EP BP by rotation also, then by FP and CP also. So by converse of DDIT, you get that this is the exact same as the involution you get from doing DDIT on the quadrilateral this guy, like EDPA. And then it just swaps, it'll swap A and D, E and B, and F and C. This is just explanation of DDIT. I had to explain it. Okay, that's good. So here's a really classic one. X36. I don't know why it has such a big X number. It's really easy. So how familiar are you guys with like mixed linear in circles? If you're not, it's just like if you draw a circle through this, and then you draw a circle tangent to this side, and this side, like this. Oh, we call this circle the mixed linear in circle of ABC, like with respect to A. And we call this point the mixed touch point. So prove that, like if you do this like symmetrically, prove these exist. Yeah, this is an EGMO problem. It was like EGMO 2012 P5, I think. Oh yeah, it's not okay. Yeah, nice guess. And how do you prove that? It's really easy. Yeah, root BC. So if you do a root BC at A, then we know that under root BC, B and C swap, right? So that means that ABC is going to go to line BC. And we also know that tendencies are the same under inversion. So if you do a root BC, then I claim the A mixed linear. This is going to go to a circle that's tangent to both AB, AC, and BC. So what is that circle? Well, it could be the in circle, right? But it's not because of like config issues and stuff. So it's actually just the AX circle. It is tangent to AB, AC, and BC. So if you know anything about root BC inversion, oh shit. Uh, yeah, okay, fixed. So yeah, if you know anything about root BC inversion, you know that like it sends lines to A's to the isogonal conjugates since root BC is like divergent with radius root BC and then plus reflection at bisector of BAC, right? So we have that this and this are isogonal conjugates. But it's obvious that A to this, these concur at the Nagel point, as previously stated. So then that means that these also concur at some point. And this point is going to be the isogonal conjugate of the Nagel point. And we call this point x56. Then prove this. This is really easy. It's Monge. Yeah, good job. So if you do Monge on, it's always Monge. The wise words of Neil Yan, it's always Monge. Like he's Monge on like everything. So what do you get by Monge? Like by Monge on this guy, this guy, this guy. Well, what is the x subset of in circle and mixed linear? So it's just A, right? And what's the x subset of the in circle and the circle? Well, that's gonna be some point. Let's call it like it's gonna be this point. Yeah, it's so this just mixed touch. So then you have that these three excellent headers, they all concur at one point. I mean, they all lie in one line, and then you're done. It's pretty cool. And X55 is the same thing, but like different. And now let's go on to X69. This one's yeah, the proof of this is also pretty funny too. Uh yeah, Greenberg theorem. Greenberg, um, don't do that. Well, it's number one, it sucks. Number two, it's like bad. So step one, do this. This is pretty easy. If do you guys want to know what this is? It's really funny. So first you have to define something called a cyclosevian conjugate. Yeah, I will explain it in like 5 seconds. It's hilarious. This is called a cyclosevian conjugate. So like if you take like this, like its Sevian triangle, then take its own circle, then we have that by like pop that these concur at one point. I mean, if it's actually drawn goodly, like the second intersections, we call it cyclosevian. And Grimberg's is like, I think it's like cyclosevian of isotomic of anti-complement. I think this is right. Oh, okay, yeah, what he said. Yeah, so yeah. So yeah, you have the cyclosevian of the isogonal conjugate of the anti-complement of the isotomic of the complement of the isogonal conjugate of a point is itself. Yeah, that's the theorem. And to use this to prove this, it's really fast because you have that the cycloseven conjugate of H is G by nine-point circle. Isogonal conjugate of G is obviously K, and anticombinant of this is that, and this is isotopic of G of is itself, right? So yeah, it's pretty dumb. Don't do that. It's bad. Here's the better proof of it. So step one, we have the by like Schwatt line that M is the median point and midpoint of BC a collinear. This is like Schwatt line is like yeah, Schwatt line is funny. Proof of Schwatt line is like if you take a rectangle, like all the rectangles with like uh that have like the like diagonal intersection point on like the A altitude or something. Wait, how was the proof of straight line again? It's like something like that. It's like you take a bunch of rectangles and you like find like the locus of like that. What was the proof of straight line again? Yeah, you like take like a rectangle and described it, and then you like the locus of all these rectangles, like all of like the centers. This is gonna be a line through like M by taking this degenerate rectangle, D by this rectangle, and K by like this rectangle. And then you get that the centers of all these line one line. That's called the Schwann line. And then you have that MKD collinear. So then to prove this, it's like trivial. It just like it's pretty easy. You just do like I think homosity from G, and then you get like this. So then you get that BMC equals this, then homosity back down from A, and you get like yeah, I think that's fine. So yeah, so this will give you this gives you this immediately, and this is the hard part, but it's also like tractable. I only have like 15 minutes I have to cook. Okay, this might look intimidating. So do you, if you can prove that these two cross ratios are equal, well then by like prism lemma, if you guys know what prism lemma is, it's just like if you have 1, 2, 3, 4, and 1, 2, 3, then if you have that these cross ratios are the same, then like you can like project from like this. Yeah, that's like prism lemma. It's pretty easy. So try to prove that these two have the same cross ratio. So to do that, it's actually easier to prove this equal to this, and then prove this equal to this. And this part is hilarious, and it's kind of unmotivated, but it's really funny once you see it. Oh, by the way, this on the diagram, it's just this. So try to find like a sequence of projections that gets like E prime PC to I B and D. And yeah, so take a guess. Well, actually, fine. I'll give one hint. What's gonna be a projection that sends E to I? That sends E to I. That's the only hint I will give, and you guys might be able to guess the rest. Well, actually, I don't know if it's guessable. It's actually pretty difficult. Oh, he's cooking. Okay, not sure. Well, let's just draw the line in. Well, what do you know about this line? Like, there's like one thing that you know about this line. Like, what's the most obvious thing you can say about this line? Yeah, it's 90 degrees with this. Okay, so what if you take a projection from the point at infinity that's 90 degrees with AC? Then what does P go to? This is hilarious, yeah. So what does P go to? Well, wait, actually P is difficult. What does E prime go to? E prime it obviously goes to IB, right? Because like in touch. I mean X touch. So P and C are actually the hard parts. You get it goes to like these crazy things. Yeah. I chose like the centers of this to be like connected, so you can use like results and stuff that are motivated. So let this be like P prime, let's be like C prime. Okay. So how do you relate? So uh we have the E prime PC is equal to IB P prime C prime. So how do you prove that this is equal to the yellow points, basically? And this one's pretty easy. Like just like look at it. Use the common geo trick of looking at it. Well, do you guys agree that like these points and these points they look kind of similar? So take a guess. Reflection DDIT. Good job. It's yeah, it quite literally is. Reflect across NB. Then I will go to IB, B will go to P, and D will go to this. Oh wait, yeah. So uh oh we have like no time left. Crap. Maybe I still like 3 more sentences to go. Crap. Okay, so once you get that, you have that this equal to this and like this is equal to that as well. So now we just want to prove that these two are equal. And I conveniently I drew those in for you as oh yeah, that's probably faster. So then I drew this in for you as like the yellow points and orange points. So now to prove that these have the same cross ratio. And I really like this. Well, what is this equivalent to by prism lemma? Yeah, by prism lemma, do you guys see how this is equivalent to uh what's it called? Wait, actually, I don't think it, yeah. Do you guys want a hint? You might have to use like one of the previous slides. Here's a hint. Look at BIC really carefully. Like, just like stare at it. And try to like reframe this whole config in terms of A and BIC. Okay, we have like 10 minutes left. Oh my God. Yeah, I have to cook. Velocity how? At A or at I? Wait, they are. Wait, is it not like I? I never said. Wait, these are like not These are like not harmonic. They're just like. Oh crap. Uh, Whatever. If they're in like the right order, what is the right order of it? It should be like. Isn't is this not right? I C. Oh, it should be like this, and this. Yeah, whatever. So yeah, this. Well, it's like the same thing. So okay, here's the hint. Note that AB and these are 90 degrees. AI and these are 90 degrees. And AC and these are 90 degrees. And what does that give you? Oh yeah, but think like projective. Yeah, it's the orthotransversal. So you have these are equal, and you're done. Okay, and here is one thing I really wanted to get to. Prove that these completely random ass points is harmonic in OI. Well, here's a hint. I have not introduced these points at all. So maybe you should like do something nice about them. Yo, should I use GeoGebra for this or not? I think it should be fine. Okay, whatever. I guess I go a bit over time. Yeah, that was faster than I thought. What were the points again? Was it? Oh, 65. Oops. Okay, there's your points. What was it? Okay, so what about hyperbola? So what would that imply about the isogonal conjugates of these on Feuerbach? So, well, you want to prove that on the Feuerbach hyperbola that ISC Mittelpunkt and the Gell point, you want to prove that this is harmonic on the Feuerbach hyperbola. So let's just draw that in. 9. Was it 7? I think it's 7, right? From A? Why from A? Okay, I think he's cooking crap. Yeah, Minipug's 9. I know that. This should be Nigel. Actually, this should be like, yeah. Shift looks like 31, right? Why is it not? What was it? 21? Oh, yeah, 21. Oh, wait. I'm an idiot. There's Nigel. That was Gergonne. So, okay. So, now you want to prove that this is harmonic on this. What the hell? So, what point and what line would you project onto? Well, take a guess. Like, what would be nice? And also, like, the main thing like that restricts like the points you choose is Schiffler. Because that means that I choose something that's like on like something nice with like relation to like BIC. Like, does it kind of make sense? Because you can't really deal with Schiffler any other way, since it's like Euler line of BIC and stuff. So, any ideas of points that have some relation with BIC? Bro, just like name any point. Okay, stop DMing. So, someone said to use a Feuerbach point. Uh, I don't think that would give you anything nice. M? Oh, wait, why did this should be midget punked? Yeah. So, well, what do you know about like what do you know about this line? Nothing. That's probably not like the best idea. So you want something at some point that has some relation to the shift loop point. And it doesn't have to be like symmetric. Just pick anything. So the thing I'm majorly hinting towards is try to guess something like what about which of these sounds more appealing? Like this is because we have that this is like the only way we have to like define shift loop point right now. So what if we just project from HA? Then this, this, this. How do we prove that this is harmonic? BC? Root BC? Uh, no, because you get that HA is gonna go to like, yeah, somewhere like really bad. So, okay. So here's a guess. You have I and OA already. So let's just like draw this line in. What's this point? Who's this guy? This is guessable. Yeah, it's IA. And then who's that guy? Yeah, he gets mid punk stuff. Because we define this as like we know that this is gonna be MA because it's perspective of MA, MB, MC, and IB, IC. Remember that? Like the beginning? Yeah. That's like definition. So now all we have to prove is HANA is parallel with line. Oh yeah, what is this line? Oh wait, it's not. It's like not nice. Yeah, so prove that HANA. Prove this is parallel with IOA. And after that, we're done. This isn't a hyperbola unit. Wait, it is? Oh, that's crazy. Nice MO. Okay. Do you guys have any ideas? It's like not that bad. It's no, it's like it's really easy. Well, step one, replace this with what? With AI. That's step one. Actually, no, you're gonna replace it with like. Actually, this might be nicer. IA and like and yeah, pick IA. Actually, first prove the reflection of NA across MA lies on AIA. Prove that. Prove like Nagel reflection across MA lies on AI. Bro, okay. It's not that deep. Because okay, once you have that, what do you want to prove it? Actually, I think it should be. Is it easy? Wait, how do you prove that NA reflect MA is on this? I think it should be. It should not be that bad. Is it just because like? Oh, I see. It's from. It has nothing to do with incident excited reflections. Sure. So okay, everyone just sending me the word complex and berry. So I'll assume it's probably just that. So okay, once you have that, it's like it's pretty easy. First, uh, what is the centroid of the reflection point? What is the centroid of this? Like, what is let's call this point, let's call it P. What's the centroid of A, P, and A? It's trivial. Yeah, he sees it. Okay, someone has seen it. Well, yeah, this is obviously just G, right? Because these are reflections. And it's like a weighted average of A, MA, and MA. So that means the centroid of this, it's gonna lie on this, right? So wait, no, sorry, it doesn't. Oh, did I not draw it in? I'll just eyeball it, I guess. Uh, it's like It's like that guy. It's like that guy. There it is. Yeah. So then you have that, and wait, no, it should be like. Why did I draw it so zoomed out? It should be like this. Yeah. So you guys know that I, G, N, A, these are collinear, right? And specifically, homosity of like -2 sends I to Na, right? This is true because of like this lemma. Like from G and then like yeah, it just homosity from like stuff. From like this guy and like something. Like that guy. Yeah, it's pretty easy. So that means by taking like the -2 homosity from G of AI, you will actually just get line HANA. So that means that HANA, like HA Nagel point, that's gonna be parallel to AI, and then that solves it because you should get that the intersection, the projection from HA, it'll just give you I, OA, IA, and then infinity point along AI. And then these are obviously harmonic since this is a midpoint, and then you're done. So this is a really cool proof. Like we went from this to like Voivod Confibula and then to like a bunch of homocities and then that solves it, which is crazy. Okay, it's 8:37. I have 7 minutes overtime, so I don't know if you have time to do this. Like this is like long. This involves Jirabek. Like uh this is okay. Um since I'm like very out of time, I'll probably just end this meeting like now. So thank you all and have a good night. And I'll post these slides somewhere soon.